think maybe we'll start. Hey, good morning. My name is Raj Krishnamurthy, and she's Krithika. We are both Golang engineers, and we work in automating security controls for risk compliance and security assurance. So that's sort of our background. So our approach to SLSA is from that perspective. How many of you have implemented SLSA in your organizations? Maybe a show of hands. Okay, one. How many of you? Two. Working on it. I think. And how many of you are sort of familiar with SLSA, the specifications? I think that's a handful. So maybe some of you may be familiar with what we are going to discuss. So if you can maybe move on to the next slide. So let me start with a quick overview of the threat model. This is from salsa.dev. You would have already seen this. And essentially, just a quick recap is that what this is doing is to outline the threats at a high-level category, right, from a source, dependency, and a build perspective. And as you may know, I think what it basically fundamentally comes down to is how do we establish trust across these different stages in the pipeline, in the supply chain. And we primarily do this through the generation of provenance and the verification of provenance. Right? And if you can move on to the next slide. So the SLSA 1.2 maturity, I think it has changed from the .1, and 1.2 essentially maps to these three levels. Level 0 doesn't even apply, right? Maps to these three levels, and they correspond to what you would typically see with the 0.1 specification minus the source requirements, right? And there are a bunch of things that are, the source track is being called out separately as a future requirement in 1.0. And basically what this lays out is that it's a sort of a maturity model where 1.0 talks about provenance being generated, but there is no guarantee on the content of the provenance, right? I mean, you're essentially generating a provenance, can be from your laptop, right? You can generate it from wherever you want. I think moving further from that is that we sort of have a trusted hosted model in which we are generating this provenance file. Again, the question is can you trust the provenance? Can you trust the builder that generated the provenance? And that's a key question that we are essentially trying to answer through the L2. And finally, the last one is that not only can you trust the build machine, can we make sure that the build machine is secure and we can trust what essentially comes out of that build machine, right? Is the level 3. What I wanted to do is to maybe, it's a lightning talk. I'm going to hand it over to maybe Krithika to talk about the structure of what a provenance is and what are observations, some of the challenges that we have seen, and maybe some of the solutions that we have thought of.
Yeah. In an ideal situation, the end user will want some assurance that the source control platform was hardened, that all branch protection rules were implemented, all the changes were authorized, all the commits were signed and verified. But in reality, there is no way one can have assurance that the platform was secure. Even if the commits were signed, whether the signature was good enough, the keys were not stolen, and code reviews were performed at least by 2 people, and it was an informed review. And similarly, the build integrity, also there is no assurance. The 2 builds could have happened one after the other, and one could have poisoned the cache, whether the build is isolated, whether there was no external access to the build platform. The internal communication. SolarWinds is an example of this attack on the build platform where they established a backdoor. So there is no way the end user, while downloading an open source package, can verify that the build platform was hardened and it was secure. All that the end user has is the provenance. Provenance is nothing but a claim made by the builder regarding the software's origin, build process, the kind of input it went into building the software. So all we can do as end users, or compliance assessors, is to investigate the provenance and see whether it matched our expectation or not. So provenance has subject and predicate. Subject identifies the image for which this provenance is being described. Predicate identifies the builder, and it also provides a recorded description of the build process. This build definition has type, configuration, environment, and build materials. Type is nothing but the template which describes how the build description. so that we compliance assessors know how we can read this build description, which is there in the build definition, and make some meaningful interpretation out of this. Configuration deals with the build steps, which is the workflow, and the repository where it picked the workflow and any external parameters that was passed to the build. Environment specifies the internal parameter and the resources the build platform used while performing the build. And build material is the source location of the source code, base images, or any other dependency that was picked for the build. Now, we were, in our assessment application, we were able to perform the following assessment based on the provenance. Check if the provenance existed and it was not tampered. Then the artifact for which the provenance is being described, whether that was tampered or we didn't download any typo squatted package. And by verifying the build material, we knew that the build was from an official repository. It was the build platform picked it up from the right source control platform. Even if the platform, source control platform was genuine, there is no guarantee that the branch is official. So that check we were able to do. It was from an official Git commit. The code was not modified after it was checked out, and the output image digest was not forged. So I mean, there is quite a possibility that adversary image can forge the digest of the genuine image. So that check we was able to do. And we were able to make sure that the build was performed by official builders, and it followed the official build steps, and the input parameters were all that expected. We were also able to make other verifications by querying the source control platform, by checking if branch protection rules were implemented, 2% review was there, all the commits were signed and verified. If the builder was known, like we can also make some interpretation about the build characteristics, and that also went into our verification. Like for example, in the case of GitHub Actions, we can know that each build happens on separate runners or virtual machine, so it is isolated. But still, there are many other things we cannot guarantee, like whether the cache was poisoned or not. So, and we were also able to integrate some findings from the vulnerability report to know if the dependencies which is being used in the package were not having any higher vulnerability score. So, in conclusion, what I want to say is, though we are able to, what SLSA 1.0 says is trust platform, verify provenance. But even to trust platform for us, like compliance assessors, we need some guarantee in the provenance. If the builder is not even making a claim in the provenance regarding his hardened level, it is very difficult for us to trust the build platform. So what we need is, in the future, more people adopting SLSA. If there are very few builders adopting SLSA, then it means there are very few SLSA compliant packages. In an application, if we use few SLSA compliant packages and few which are not, then still the application is not secure. The provenance should contain some information about the builder's hardened level. It can be accredited by a third party, or at least a self-attested hardened level of the builder should be present in the provenance for us to have some guarantee that the build process happened properly. We need to bring back source track soon. This is older version of SLSA had a source track which had some guidelines regarding how the source should be produced and how it should be stored. But the latest version of SLSA simply focuses on the build track. So this, as an end user, we need some guarantee and assurance regarding the source integrity. So this needs to come back, at least in the next future version. And some sections in the provenance, like the build materials, from where the artifacts were picked up from, build configuration, and environmental details, these are all mandatory. Most of the provenance have all these information, but still there are very few which don't have one or two of these sections. So it makes it very difficult for us to get complete value out of the provenance. So if all these gaps are bridged, I'm sure SLSA verification will be very fruitful, and it will make software security chain very reliable. Yeah, this is all Do you have
Maybe
any?
I just want to add one more thing. I think there is a level 4 in the 1.0 specification that is being worked on, which is around the reproducibility of the build, because we need to be able to corroborate or audit the provenance, and the reproducibility is sort of super critical for us to be able to do that, right? So from an assurance and compliance perspective, those are the things that we would really like to see moving forward and in the 1.0 spec.
So any
Do we-
questions?
Yeah.
Any?
Okay, no, thank you.
Okay, thank you very much.